Welcome to this video. In the previous video, we have shown how we could model deep drawing a box considering damage mechanics. In that video, we explained how we could create damage initiation and damage evolution rules, and also we show how we could create parts and assemble them. In this video, we are going to add element deletion to this problem, and also we will discuss some aspect of meshing the rigid parts. We also describe how we could show element deletion and progress of damage in visualization. This assembly was created in previous video, and we go to the step module and create a dynamic explicit step. We reduce the time of a step to have less computational cost. Then we request two field outputs for better presentation of damage evolution and also element deletion in visualization module. The first is scalar stiffness degradation and the second is status of the elements. Interaction module, we define two contact properties. The first is between die and blank, and also blank holder and blank, with the friction coefficient of 0.05. And then we create a contact property between punch and blank with higher friction coefficient. This time we set the friction coefficient to be 0.25. And now we can create contact between parts. At first we create contact between punch and blank with surface to surface contact in explicit procedure. Then pick all faces of punch and pick the brown side. After that we can pick the blank as a slave surface. The kinematic contact method is more accurate, and also we choose punch blank contact property. Then we create contact between blank holder and blank. The blank holder is a flat plate. We pick the purple side and then we pick the surface of the blank and brown side. And we choose die blank contact property. And finally we create the contact between die and blank. We should pick all faces of the die. And the brown side. Then we pick the blank as the slave surface, and this time purple side. Now we can go to the load module. In load module, we should fix die and blank holder at first, as we want to fix all 6 degrees of freedom of die and blank holder. We pick reference points of them and apply incaster constraint to them. Now we create movement for the punch. We pick the reference point and fix 5 degrees of freedom, and only in Z direction we apply displacement to the punch. For applying displacement we should create amplitude, and the smooth step is suitable for dynamic explicit procedure. The amplitude will be multiplied by the magnitude of the load. In the last step, we should apply symmetric boundary condition to the sheet. As we modeled 1/4 of the problem, we should apply symmetric boundary condition to the edges of the sheet. We apply Y symmetry to this edge. And then X symmetry to this edge. In the mesh module, we should mesh the sheet and also all rigid parts. Please notice that for accurate modeling of the contact between a discrete rigid part and a deformable part, as you can see in this figure, we need fine mesh in complicated region of the rigid part, and for flat faces of the rigid part, coarse meshes are also sufficient. So we use coarse meshes for blank holder and flat parts of the die and punch, and for fillet of die and punch we apply seating edge and use fine meshes. After meshing all rigid parts, we mesh the blank. We use quadrilateral and structured elements and use explicit, shell, and linear elements. Then we choose element deletion and specify the maximum degradation value for deleting elements. For accurate modeling of contact between sheet and tools, and also for accurate modeling of damage in the sheet, we should use sufficiently fine mesh for the blank. Now we can go to the job module, create a job, and submit the job. In visualization module, we can plot the deformed shape of the blank. As you can see, the blank is separated to two parts. We can hide tools and show only blank, and see deformation in different steps of forming. The first interesting thing is shape of the edges of the part. We can compare this shape with the experimental shapes, and we can observe its similarity. Next, consider blue elements. They are elements with reduced stiffness, and we expect that these elements be deleted in next increments. Finally, the crack propagates across the sheet and the sheet is separated to two parts. I hope you guys have enjoyed this video. If this video has helped you out, please let us know by a like, a comment or a subscribe. See you in next videos.